Guys, in this video, we're going to keep it with grams and moles and formula weight. We're not going to expand on it any, but I'm going to do this backward than what we've done in the previous videos, all right? So in the previous examples, what's happened is that we have given you moles, and we have asked, well, how many grams does that represent, right? Well, in this set, I just want to show you it's as easy to go the other way, and I'm going to give you the number of grams, and we have to calculate how many moles we have used in our experiment. So the same concept, the same steps, the same numbers we're going to be using. It's just a different setup. That's basically it. One step kind of gets flipped and the rest of everything else stays the same. So these problems are no more difficult than the others. It's still using formula weight. As long as you set up the dimensional analysis the right way, you've got it. So let's try to tackle the very first one, the very first example. So let's say I have 200 grams of fluorine in the lab, and I want to know how many moles would that be, right? If we use 200 grams in an experiment, and I want to write up a formal lab report or tell someone how many moles, or maybe we need the number of moles for a future calculation, I need to be able to go from gram to mole. So that's backward than what we did the previous two videos. And that's okay, not a big deal, right? So I take my given in the problem, 200 grams over 1, just like before. Just like before, I bring in my next dimensional analysis step. Just like before, whatever goes on top here, gram, goes on the bottom here, gram. And I need to get to mole. So the question is, can I go from gram to mole? And the answer is yes, I can do that as long as I know the formula weight of the compound. So I need the formula weight of F2. All right, so let me bring up my calculator here, and I'll find fluorine, which is right there in the corner, top of the halogens. And that's 18.998403. So that's going to round off to 19 even. Well, there's two of them. It said F2, right? So that's 19 and 19. So that gives me a total of 38. 38 is the formula weight. So 38 grams is in 1 mole of fluorine. You have to make sure that you're putting the numbers at the right location. That's what all of this is about, right? So formula weight, 38 grams is 1 mole of fluorine. That's what formula weight stood for, right? Well, here is the gram unit. That's where formula weight needs to go. There's my mole unit. So this is always in terms of 1, so a 1 will go there. So in order to solve this problem, I need to take 200 and I need to divide that by 38. And I'm going to get 5.26 as an answer. So 5.26 moles of fluorine, F2, is what we have in our hands at that moment in time. All right, so let's do another. This time we're going to do 25 grams of lithium. We want to know how many moles is that. All right, so just like before, 25 grams over 1, dimensional analysis, gram on top, gram goes on the bottom. Well, how many grams of lithium are in 1 mole of lithium? That's the formula weight, right? And this time it's just Li. It's just lithium. That's it. Nothing more than that. So I need to find lithium. It's up here at spot number 3. And that weight is 6.94. Well, that's all there is to it, right? It's just 6.94. There's nothing else with lithium. It's just Li, and there's just one of them. So 6.94 is going to be the formula weight. So formula weight, 6.94 grams per mole. That's what that means. There's my gram. So 6.94 goes there, and that's in every 1 mole of substance. All right, so I'll come to the calculator. I'll take 25, and I'm going to divide that by 6.94. I'm going to hit enter, and I'm going to get 3.60 as an answer. So 3.60 moles of lithium is what we have in our hands when we weigh out that amount. All right, let's do another. 180 grams of calcium. How many moles would that be? All right, so 180 grams over 1. I bring in the next step, gram on top, gram on bottom. I need to go to mole. In order to do this, I need formula weight. That's the only key step. Well, this is just for calcium. There's nothing else with it. It's just Ca and Ca only. So if I go to the periodic table and I find calcium, my weight is 40.078. I'm going to round it, and that turns into 40.08. So 40.08. So 40.08 grams for every 1 mole. That's what formula weight represents. I keep saying it over and over and over. So in this step, 40.08 grams, because that's the number that goes there, for every 1 mole. There's my mole. I put a 1 in front. So I'm going to take 180, and I'm going to divide it by 40.08. I hit enter, and I'm going to get 4.49 as an answer. So 4.49 moles is how much stuff we have present when we weigh out 180 grams of calcium. All right, so we're going to continue on, and this time I'm going to bring in an actual compound. So my fourth one is going to be 200 grams of NaOH. All right, so I need to know how many moles are represented here. How many moles do I have if I weigh out that much? So 200 grams over 1. Bring in the step, gram on top, gram on bottom. I need to convert it to mole. And in order to do this, I need the formula weight of sodium hydroxide, NaOH. So I'll go to my table. I calculate the formula weight of NaOH. So that's 22.99 for sodium. I've got 1 oxygen, so that's going to be rounded to 16. And then I have 1 hydrogen, and that's going to be rounded to 1.01. Add them all up, I get 40 as an answer. So my formula weight here is 40 grams per mole. So in this step, there's my gram. So 40 is going to go there per 1 mole. So a 1 goes there. So I'll bring up my calculator if you need it. 200 divided by 40. Enter. That gives me 5. So 5 moles of NaOH is what we've used. Next one. Let's say that we have 100 grams of MgCO3. And I need to take gram and convert it to mole, just like we've always done so far in this video, right? So 100 grams, gram on bottom, mole on top. I need the formula weight of MgCO3. All right, so let's calculate that. I need to find magnesium. There it is. And magnesium is 24.31. All right, the next one, MgC. I've got 1 carbon. So I need to find carbon. There it is. 12.01. And then if I go back to the problem, it looks like there's 3 oxygens in total. So I need to find oxygen. There it is. 16. So there's 1, 2, and 3. So that's 84.32. That's the formula weight for this compound. 84.32. And that's gram per mole. So in the step, there's my gram. 84.32 needs to go there for every 1 mole. So 1 goes there. So to solve this problem, I'll take 100 and I'm going to divide it by 84.32. I hit enter, and that gives me 1.19 if I wanted to round that off. So 1.19 moles is what I have of MgCO3 if I weigh out 100 grams of the stuff. Then finally we do one last one, and that's 50 grams of ZNO, zinc oxide. The stuff in sunscreen. some of it. So I'll take 50 grams over 1, bring in the next step, gram on top, gram on the bottom. I need to go to mole. To do that, I need formula weight. I need the formula weight of ZNO. So I need to find zinc. There it is at number 30. That's 65.38. And then I have 1 oxygen attached to that. So that's going to be a total of 16. And that's 81.38. So that's the formula weight. Formula weight is 81.38 gram per mole. So here's my gram. That means there's 81.38 grams in every 1 mole. So I'll set up the dimensional analysis, and I'll take 50, and I'll divide that by 81.38. I hit enter, and I get 0.614 as an answer. So 0.614 moles of ZNO in that amount. All right, so I think that's enough examples for you to use to do the next set of problems, which is taking it, just like what we've done here, a number of grams and converting that into a mole. And I think if you can do these 6 problems through here, and as long as you understand how to calculate formula weight, I think that you'll be okay with this section. So that's it for this video and this section of calculations. Again, we're playing a focus. It's like Sean T. Focus, 25 minutes. That's what I want you to do. You've already spent 11 with me, so in the next 15 or so, I want you to turn your attention to the example problems and solve them out before you forget how to do this. That's the best case scenario. So good luck with that assignment. Give me a 100. You'll be proud of yourself, and I'll be proud of you. And then we'll continue on to the next set of calculations.